Hello everyone, hope you all are having a wonderful day. And on my last video, we have discussed about the theoretical explanation on exercise 1.4, that is what are Venn diagrams and what are the different operations on sets like union and intersection of sets. And then we have also learned some properties of both these kinds of operations. Right, now it's time for us to use all this knowledge and do the work problems based on exercise 1.4. So let's directly go to the work problems based on Venn diagrams and operations and sets. The first problem is find the union of each of these following pair of sets. So we have to find the union of each of these pairs. So x is given, y is given, so you have to find what is x union y. What is actually a x union y? Union is what? The elements which are both belongs to set x and both belongs to y. You don't have to repeat an element. For example, 3 is there in both the sets, so you don't have to write it 3 3. Elements are immaterial and you can replace or anywhere you wish, and you don't have to repeat it. So what are the elements of common elements, sorry, not common elements, which belongs to both x or y? So what are they? 1 is there, 2 is there, 3 is there, and 5. So x union y is what? 1, 2, 3, 5 are the answers for this problem. Now let's do our second problem. A is equal to AEIOU and B is equal to ABC. So what is A union B? So what are the elements? A is already there, then B, then what is the next element? C, then E, I, O, and U. So these are the elements of the subset A union B. Now let's discuss the third section in it. A says that x is a natural number and a multiple of 3. So what are the elements of this set? 3, 6, 9, 12, and so on. So it's an infinite set because it is said that x is a natural number. The set of all numbers in a natural number set is a infinite set, right? So 1 till the highest number, that is the till infinity. B is what? X says that x is a natural number less than 6. So this is a finite set because it is said that it is less than 6 and it is a natural number. So 1, 2, 3, 4 and 5 because it is said that less than 6. So 6 is not included. Okay, so what are the common elements of it? A union B is what? A union B is 1, 2, 3, 4, 5, 6, 9, 12, and so on. The rest all the multiples of 3. So these are the elements of the subset A union B. Now let's discuss the fourth section on this. A is that x says that x is a natural number 1 less than x less than 6. So what are the elements? It is with equal to. So A's elements are 2, 3, 4, 5 and 6, right? And what are the elements of B? 7, 8 and 9. 6 and 10 are not included because it is written, the intervals are written without equal to. So these elements does not belongs to these intervals. So they are open intervals, and in the above question you can see that closed interval. So if you have any doubts on what are open intervals and closed intervals, please have a look on my previous videos. Or if you find any difficulty to find the videos, please go to my channel and check on the playlist. On the playlist, I have made a playlist on NCERT Max Class 11th Chapter 1 sets, where you can see all the exercises are arranged in orderly manner and you can refer from the starting video until the end of this chapter. So this is just a quick reminder if you are just watching my video for the first time. So now let's back to the question. So let's take the A union B. What is A union B? Is 2, 3, 4, 5, 6, 7, 8, 9. So these are the elements of this subset A union B. Okay, now let's discuss our fifth problem. A is 1, 2, 3 and B is an empty set. 5 is actually what? 5 is an empty set itself, right? So you write present it like this. What is A union B? The set A union of an empty set is the what? The same set itself, that is A itself. That is 1, 2, 3 itself. So that's all for the first section. Now let's discuss the second part of the question. Let A is equal to 1, 2, let A is equal to AB, B is equal to ABC. Is A a subset of B? Is A a if for a set to be a subset of another set, all that elements of a set should be also belong to the second set too. You can see that A and B both are there in set B also. So you can say that is A a subset of B? Yes, it is a subset of B. What is A union B? So when they are a subset, you can say that A union B is what? B itself. Set B itself, that is A, B, C. So that's the answer for the second part of the question. And now let's discuss the third part. If A and B are two sets such that A is a subset of B, then what is A union B? It is already mentioned in the above question. So A is a subset of B. Yeah. And what is A union B? I will draw through Venn diagram. That is better. So you have a subset B and A is actually a subset of this one. So what is A union B here? B itself, set B itself is a union of it. I hope it's clear. Now let's discuss the fourth part of the question. If A is equal to set 1, 2, 3, 4, B is a set 3, 4, 5, 6, C is a set 5, 6, 7, 8, and D is a set 7, 8, 9, 10. So we have to find the union of all these sets. Now A union B, what are these? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 are the elements of the set A union B. 1, 2, 3, 4, 5 and 6. You just have to include all the elements of A and B. For A union C, it is similarly the same. You have to include all the elements of A and C. So what are the elements? 1, 2, 3, 4, 5, 6, 7 and 8. Now again, what is B union C? B union C is what? 3, 4, 5, 6, 7 and 8. Again, B union D. All the elements of B and D. What are they? 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9 and 10. Again, what is A union B union C? So you have to take this, you can use using any laws also. Okay, I have already found what is B union C. B union C. What is that? 3, 4, 5, 6, 7, 8. With that, you have to take the union of A. That is, you have to include 1 and 2 also with it. 1, 2, 3, 4, 5, 6, 7, 8. So for such kind of problems, you have to see that already you have found something. In this, my previous problem, I have already covered what is B union C. So you have to just take now what? A union B union C. Or either you can do is like, you can take first A union B. What is A union B? Then you can take the union that with the set C. It will also give you the same answer. So any method you can use. Okay. So now what is A union B union D? A union B, I already know what is 1, 2, 3, 4, 5, 6. And if you take the union with that, what are the elements? The complete set. 1, 2, 3, 4, 5, 6. Complete set, not complete elements. Or 7, 8, 9, 10. So all the elements are used. That is A union B union D. Again, what is B union C union D? B union C we already know. So again, what? So 3 from the elements 3, 4, 5, 6, 7, 8, 9 and 10. So these are the elements of the subset B union C union D. With this, the fourth question is over. And now let's discuss the fifth problem. Find the intersection of each pair of sets of question 1 above. So in question 1, we have discussed all the union of the sets. Now the question is said to find the intersection of each of the sets. Okay. So let's directly go to the question. X equal to 1, 3, 5 and Y is 1, 2, 3. So what are the common elements of both these sets? That is called the intersection. So X intersection Y. So 1 is common for both the elements, and again 3 is also common for both the subsets. So 1 and 3 are the intersection of elements of the subset X intersection Y. Again, A and B, what are the common elements in it? There is only one element, right? So A intersection B here is subset with A, only the element A in it. Again, the third problem, X says that X is a natural number and a multiple of 3. Here X is a natural number less than 6. Here only common element is what? 3 is the only common element in this both sets. So what is the answer? A intersection B is here what? The subset with element 3. So I hope it's clear. Now the fourth portion. A. X says that X is a natural number and 1 less than X less than or equal to 6. What are the elements? 2, 3, 4, 5, 6. Right. So B is such that X is a natural number where the elements are 7, 8 and 9. So are there any common elements between them? There are no common elements. And so you can say that A intersection B of the set is an empty set or a null set or a void set. So the last problem in it, A equal to 1, 2, 3, B equal to 5. Again, can you find any, when you take the common of an empty set and a set, again, what is it? If you take intersection with an empty set, always the elements would be what? An empty set or 5. That is null set. Okay, so that's all for the fifth problem. Now we have covered till fifth problem. Let's do the sixth problem. If A is equal to 3, 5, 7, 9, 11, B is equal to 7, 9, 11, 13, C is equal to 11, 13, 15 and D is equal to 15, 17. Find A intersection B. So similarly, how did you find the union? In these problems, we'll find the intersection, that is the elements which are common to both the sets. So for the elements A, 3, 5, 7, 9, 11. What are the common elements in it? The common elements are 7, 9 and 11. I hope it's clear for you. Again, for B intersection E, the elements common for both the set B and C. What are they? 11 and 13, right? So 11 and 13 is the answer for this one. Again, A intersection C. So let's do A intersection C intersection D this. So first let's find what is A intersection C it is. Can you find any common elements? Yes. So A intersection C is 11. Only 11 is common in both this. And if you take the intersection with 15 and 17, no, there are no common elements and this is a empty set of 5. Again, A intersection C. A intersection C we have already done and that is what? It is 11. Now let's do the fifth problem. B intersection D. B intersection D, you can see that B 7, 9, 11, 13, D is 15, 17. So there are no common elements in it and hence it is a empty set, right? So you can write it by 5 or also you can represent it by empty set, okay? Next, A intersection B union C. So this is what? This is actually same as, you can put brackets and then you can write A intersection B union A intersection C. You can see that 7, 9, 11 is union with, that is what? 7, 9, 11 itself. You can use all the properties which you have used. I have used one of the property like associative property here, right? A intersection B, sorry, distributive property. A intersection B union C is what? A intersection B union A intersection C. Now what is A intersection D? Again, there are no common elements between the set A and D. The answer is 5 or empty set. Again, A intersection B union C. A intersection B union D. I represented wrong. Again, use the distributive law. A intersection B union A intersection D. What is A intersection D? A intersection D is 5. A intersection B is 5. 5 union. A intersection B is what? 7, 9, 11. So what are the elements of it? 7, 9, 11 itself, right? 7, 9 and 11 are the elements of this subset. Again, the next problem in it. A intersection B intersection B union C. What is A intersection B? That is 7, 9 and 11, right? Again, that intersection with B union C. What is B union C? 7, 9, 11, 13 and 15. So if you take the intersection of that, what you will get? Again, the set with 7, 9 and 11. So that's the answer for the problem number 9 in the sixth problem. Again, the last problem, that is the 10th problem. A union D intersection B union C. So what is A union D? So all the elements of A and D: 3, 5, 7, 9, 11, 15, 17. Again, taking the intersection with B union C. What is B union C? 7, 9, 11, 13 and 15. Take the intersection of that. So what are the common elements in these both sets? 7 is there, 9 is there, 11 is there. So again, 13 is there. So sorry, 13 is not there, only 15 is there. So 7, 9, 11 and 15 are the elements of the subset A union D intersection B union C. I hope now we are pretty much clear with how to deal with problems when you have to use with properties, and also how to do problems with the union and intersection of sets. So that's a main motive of learning this exercise 1.4. This is an easy section, I hope. Now let's discuss the seventh problem in it, such that if A is equal to X such that X is a natural number. Okay, so B is a X such that X is an even natural number. C is a set that such that X such that X is an odd natural number. And D is a set that such that X is a prime number. So you have to find what is A intersection B. A intersection means the common elements of both the sets A and B. What is that? A intersection B is B itself. Right. So, okay, if not to have any confusions, first let's write all these sets. X such that X is a natural number. So, what are the numbers? All the natural numbers starting from 1, 2, 3, 4, 5 till dot dot, because there are infinite number of elements. So, you can't represent all the numbers in a set. So, you represent it using dot dot. Again, B. X is an even natural number. So, what are the even natural numbers? 2, 4, 6, 8, 12, 10, 12 and so on. Again, what is C? C is the set of X is an odd natural number. 1, 3, 5, 7, 9, 11, 13, 15 and so on. These are the odd natural numbers. Again, prime numbers, and that X is a prime number. So what are the prime numbers? 2, which are divisible. They have only their factors and 1. 2 and 1. For example, if you take 2, factors are what? 2 and 1. If you take 4, what are the factors? 2, 4 and 1. But for the prime numbers, they have only 1 as the other factor. So 3, 5, 7, again 11, 13 and so on. These are the prime numbers. Again, if you take A intersection B, what you will get? Actually, what you can see that A is such like a universal set in the problem. So if you take intersection with the universal set with any number, you will get that same set itself. So intersection B is same as A and B itself. Again, what is A intersection C here? Again, as I said, A is actually here like a universal set. Universal set is a basic set which we take for consideration. So all these sets B, C and D in the problems, you can see all these sets are derived from the set A. What is that? X as that X is a natural number. So if you take the intersection with C, you will get that same set C itself. So A intersection C is what? C itself. Again, what is A intersection D? Again, no doubts, it is set D. B intersection C. B is what? Set of all even natural numbers, and C is X is a odd natural numbers. You can see that they don't have any common elements, and you can represent it using the empty set or the null set. Fine or anyway, both the representations are fine. Again, B intersection D. B is what? B is a set of all even natural numbers, and D is X is a prime numbers. Do you know any even natural numbers? Even natural numbers, and that should be also a prime number too. Yeah, you do have an element in it. What is that? The element 2. It is also an even natural number, and it is also a prime number. So the element 2 is the, so there is a 2 is the element of the subset B intersection D. Now C intersection D, that is a X as that X is a odd prime number. So they are also odd number and they are also prime numbers. So what you can write? 3, 5, 7, 11, 13 and so on. So this is X as that X is a, or simply like X as that X is a odd prime number. So this is the answer for the last section in this problem. Okay, now let's discuss about the 8th problem in it. Which of the following pair are sets are disjoint? We have to find what are sets are disjoint and joint sets. What are joint sets? That is, for joint sets, when you take A intersection B, there will be some common elements in it. For disjoint sets, there will not be any common elements. So that if you take A intersection B, that will be equal to an empty set. That are disjoint sets. So 1, 2, 3, 4 and X says that X is a natural number, that is 4 less than or equal to X less than or equal to 6. So what are the elements of it? 4, 5 and 6, right? 4, 5 and 6. So are they disjoint sets? No, obviously no, because you can see that the element 4 is in both the sets, and here A intersection B, that is not equal to 5. So which of the following pairs are disjoint? Not just disjoint set. Right. So the next problem, A, E, I, O, U and C, D, E, F. Can you find any common elements in it? Again, I can see the element E on both the sides. So they have some common elements and it is not a disjoint set. Again, the next problem. X says that X is an even integer and X says that X is an odd integer. Do you find any common numbers between odd and even numbers? No. So obviously it is a disjoint set. It is a disjoint set. Okay, so the next problem. So there was only 3 sections and we have finished that. Now the next problem. If A is equal to 3, 6, 9, 12, 15, 18, 21, B is equal to 4, 8, 12, 16, 20, C is equal to 2, 4, 6, 8, 10, 12, 14, 16, D is equal to 5, 10, 15, 20. Okay, so we have to find now the differential of sets, difference of sets, A minus B. What is A minus B? Set of all elements of A which are elements of A but does not belong to the set B. So you have to find if there are any elements which are common for them, that should be avoided. Okay, so now let's directly write the answers for these problems. These are a little bit lengthy, but it's very easy to find. So what is A minus B? All the elements of A and these elements should not be existing in B. For example, 12 is there in both, so you have to avoid that. 3, 6, 9, again 15, 18 and 21. So these are the elements of the subset A minus B. Now let's write for A minus C what it would be. A minus C is what? A is 3, 6, 9, 12, 15, 18, 21. Again B is, C is 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. Again, you can see here 12 is common over here. So you are avoiding this 6 and 12 from that. And you are writing what? What are the elements? 3, 9, 15, 18 and 21. So these are the elements of the subset A minus C. Now for the subset A minus D. So what are the common elements? Do you see any common elements? Yes, I do see 15. So you can avoid 15 and write all the rest of the elements 3, 6, 9, 12, again 18 and 21. So these are the elements of A minus D. Again for B minus A, all the elements of B and these elements should not be included inside A. So what are the elements of B? 4, 8, 12 is there in A, so you can't include with B minus A. So 4, 8, 16 and 20 are these elements of B minus A. What are they? 4, 8, 16 and 20. Also a quick reminder, if you wanted to learn maths, actually you have to take a pen and paper or have a practice it with your tab or any material. You have to take a pen and paper or you have to use a tab. Please do practice it. It's like maths is all about learning by doing. So if you do more, you will get to know more about maths and it will be more interesting. So rather than just hearing on my videos, I would highly recommend everyone to take a pen and paper and practice it with me while I'm doing it over here. Yeah, it's just my quick reminder in between. So now back to the problem C minus A. What is C minus A? You can see that 2, 4, 8, 10, 14 and 16 are the elements of C minus A. That is all the elements of C and these elements are not in A. D minus A. Similarly, what you will get? 5, 10 and 20. These are the elements of D minus A. What are the elements of B minus C? B is what? 4, 8, 12, 16, 20. What is B minus C? C is what? 2, 4, 6, 8. You can see that only the elements 20 is there, rest all elements included here. 4 is there, 8 is there, 12 is there. So all the elements. So only the element 20 is the element of the subset B minus C. Again, what is B minus D? B minus D is what? All the elements that are 4, 8, 12 and 16. What is C minus B again? All the elements of C and that does not belong to 4 you can write, 8 you can write, 2, 6 you can write, then what else you can write, 10 you can write, and then you can write also 14. So these are the elements of that. 2, 6, 10 and 14. So what is D minus B? D minus B means all the elements of D. D minus B is what? 5, 10 and 15. What is C minus D? C minus D is what? All the elements of C and which does not belongs to D. So 2, 4, 6, 8, 12, 14 and 16. Again in reverse, what is D minus C? That is what? All the elements like 5, 15, multiples of 5, 5, 15, 20. All these elements are the subsets of D minus C. Now, so that's all for this problem. Now let's discuss the 10th problem in the exercise 1.4. That is, if x is equal to the set A, B, C, D and y is equal to y, F, B, D, G, find x minus y. Again, it's a repetition from the previous question. What is that? X minus y is what? It's very easy, right? X minus y is all the elements of x, and these elements does not belongs to the set y. That is not in x intersection y. So what are these elements? Okay, so what are the elements? X minus y is what? A and C are the elements of the subset. Again, y minus x, if you take in the reverse order, what are the? F will be there, B can't be there because it is also an element of x, so this can't be included with y minus x. Again, D, this is also an element of x, so this can't be also included. So what are the elements? F and G. Again, what is x intersection y? Which are, that is the elements which are common to both x and y. What are they? B and D. So that's all for the problem number 10. Now let's discuss our 11th problem. If R is a set of all real numbers, Q is a set of all rational numbers, then what is R minus Q? R is actually what? The set of all rational numbers plus irrational numbers. Irrational numbers, sorry, it is represented by T. So if R minus Q is what? The set of all irrational numbers. Rational numbers were actually what? Rational numbers are the numbers which are written in the form P by Q. If you can write a number in the form P and Q where P and Q both are integers, then you can say that this is a rational numbers. All other numbers, for example, root 2, pi, these are all examples of irrational numbers. So our answer is already found. The set of all irrational numbers is the answer for the problem number 11. And our last problem in our exercise, that is the 12th problem. State whether each of the following statement is true or false. Justify your answer. 2, 3, 4, 5, 6 and 3, 6 are disjoint sets. False, right? Because you can already see that element 3 is already present in both the sets and the statement is false. Again, A, E, I, O, U and A, B, C, D are disjoint sets. No, again, A is element of both the sets and it is not a disjoint set. 2, 6, 10, 14 and 3, 5, 7, 11, 15 are disjoint sets. Yeah, obviously these are both disjoint sets because you can see any elements which are common in both the sets. So, true. Again, 2, 6, 10 and 3, 7, 11. Again, you can see that the A intersection B. If you take this set as A and this section B, if you take the intersection of both these sets, you will get the empty set. Again, so this is a true condition. So that was all about for this section, and we have completed the exercise 1.4. Now we will be doing the theoretical explanation for the second exercise, that is on exercise 1.5, where we will be discussing about what are complement of a set and then some properties of a complement of a set, and also about what is a De Morgan's law. So that's all, and let's see you on my next video. Bye bye.